selected values of the twice differentiable function f and its derivative f prime are given. What is the value from 0 to 6 f prime of x dx? What do you guys got? What do you got? Huh? What you got over there? Huh? 24? What you got? You got nothing? Negative 4? 12? Let me see. Read it. What you got? Let's see. 5, 4, 3, 2, 1. I mean, you got two choices. Which one is it? Huh? But I was gonna say, it has to be. So let's see. So if we got this no, from 0 to 6, and we got f prime of x dx, this is the fundamental theorem of calculus part B, or part 2 that we did, that this is the derivative. F prime of x is the derivative. If we can find the antiderivative, then we can just evaluate it, f of 6, which is f. The antiderivative of f prime would be f, so it has to be f of 6 minus f of 0. And then we have that f of 6 is 2 minus f of 0 is negative 22, which would be 24. All right, let's get going. Gotta get going with this now. Okay, here. These are, now we're going to apply antiderivatives to straight line motion. We have these two statements which are equivalent. This is exactly what I just did in the warm-up. That if we find the antiderivative, then we can just evaluate f of b minus f of a. And if we tie it together to straight line motion, we say that this s is position, the position function. And so if we have a velocity is the derivative of the position function. And so if we can find the antiderivative of velocity, we can just evaluate at the upper and lower limits. Another way to rewrite this, both of these, is to just move this f of a over to the other side. So if we do move it to the other side, plus f of a, plus it to the other side, then we have f of b will equal to f of a plus integral from a to b of f prime of x dx. Same thing over there. One way to look at this equation is that if you're looking for the well, I don't want to get too involved. We'll do this in a minute. We'll go over it. I'll talk about it. So we got that. The same thing over there. Okay, well, it's right here. Position at time t equal to b. The position, because we're telling this is position, S is position, is given by this same thing over there. The position at time b. Yeah, you could even you could think that this is like a time equal to beginning put time, a time equal to the beginning. You're at this your position, I guess. And then this is the accumulated one. Let's just do problems. It's better to just kind of do problems here. The problem one, a particle is traveling along the x-axis with velocity given by that for time t greater than or equal to 0. If the particle is at position x equal to 2 at time equal to 0, there it is, there's the A. This would be your A, and that's f of A. What is the position of the particle at t equal to 1? So I'll write down the second formula again. The formula says something like S of B will equal to S of A, the integral from A to B of V of t dt. So t equal to 0, then this would be your t. This is A. I can put A here. T, it is t, and this would be B. Oh, that's 8. We could. Okay. S of what? Use some time to copy the problem down. We're trying to find what is the position of a particle at t equal to 1. This is S, not. So what do we plug in for B? Because we're trying to figure out what is the position at 1 equal to S of A is what? 0. Okay, S of 0. And then this A is what? 1. And then V of T is what? I guess we could put parentheses on that. Yeah. So S of 1 equals, what is S of 0? What's the position at 0? 2. So S of 0 is 2 plus integral from 0 to 1. Well, why don't we already integrate that? I'm going to use brackets here so it doesn't get confusing that that's separate and we're doing something here. Let's see here. Let me use even a different color. Plus, let me use brackets. We got to integrate. It's a very easy integral here, no? What's the integral and then evaluate it here. So what's the integral? What's the integral of this? That's what we just did, no? The integral is the antiderivative. What do? Add to the power, we add 1, so it'd be what? T to the third, and that same number goes at the bottom. And we already have a 3 here in the very front. And then what? 6, and then T. There's 1 plus 1 is 2. Put that number at the bottom. And then we're going to evaluate it from 0 to 1. This cancels out, no? This cancels out. So we got what? Let's continue on. 2 plus. Is the upper limit minus the lower limit. So we're going to plug in 1 for here, the whole thing. So it'll be 1 to the third. Okay, that cancels out. The 3's cancel out. Plus. And then 6 divided by 2 is 3. So it'll be 3. T is 1. Square it. Okay. So this is for the upper limit. Maybe I could use, well, not necessarily. This is just being very careful with evaluating. This is the algebra part. Then we're going to subtract where we evaluate 0 in for every t, and it's going to go to 0. You guys see it, no? Because t is 0 and that's 0 and that's 0. This whole thing is 0, no? So we just gotta evaluate this, get an answer. What is that? 1 squared is 1, 3. 3 plus 1, 3 plus 1 is? And 4 plus 2 is? 6. So there it is. So what is the position of particle at t equal to 1? 6 whatever. It doesn't even give you, is it meters or what is it? Okay, so in my notes, I usually try to put this one in the back. I try to put it over here so you don't get confused with it. Sometimes you get confused when you put it here and you try to evaluate it with everything here. Probably this one, whenever you get an answer here, you always just kind of put it here in the back and then work this out. All right. All right, let's go to number 2. A particle travels along the x-axis so that its acceleration at time t greater than or equal to 0 is given by that. Its initial velocity is given by this. Its initial position is given by that. What is its position function s of t? Okay, so we're already we're at position, then we're at velocity, then we're at acceleration. So what we're gonna have to do is come back from this all the way to this and then all the way to s of t. So we gotta integrate it 2 times. But it's the same idea, no? We're not going to say s of t equals, or s of a equals s of b or whatever. We got to do, just treat it as v of a, the velocity is equal to the velocity plus integral a to b, a of t dt. And we're going to put in those numbers. A particle okay, so what do we do? Via what? Well, what is it that we're trying? Well. Are we trying to find an actual, we're trying to find a position function. We're not trying to find exactly what position is it at a certain exact time. It's just a general one. So A should be what? for any general time. VLT. Let's see. All right. So then that's equal to. Why did I write down this here? Why is this here? This should be what? This should be what? Okay. So what do we put here? So what do we put here? What do we put here? 0? And then we put what here? Yeah. And then leave this as a variable t. Yup. So A of t is what? dt. So integrate. Let's go ahead and integrate. Okay, let's do it. Let's do it the way I'm telling you to do it. Better. It's better. Don't even worry about this -6 because that one's just gonna put it over there. We really got to worry about integrating this. So then, let's say, what is this? Would it integrate? It will be what? So quickly look. We're gonna. There's a 1. 1 plus 1 is 2. So it'll be 2. 2. That 2 is gonna go at the bottom. 6 divided by 2 is 3. You gotta practice doing this quicker like this. This is gonna be what? Plus what? 14. And then it's evaluated from 0 to t. And put that plus 6 here. When you do plug it in, well, it's just kind of like t is t, and if you put in 0, the back part is going to go away. So really, then the answer is just 3t squared plus 4t plus 6. Is this v of t? Yes or no? Yes, -6. Yes, -6. That makes sense, no? Two more because it's plug what, and then plug in 0 is just 0, and there's nothing. Okay, so what are we gonna do? We're gonna do it again, and we're gonna go from v to what? To s. So we're gonna go what and say what s of t? Because we want a position function s of t. I'm just gonna go s of t. S of t equals. But you were given some information here, no? What is it about position? Is what? So 0 is 9, no? Yep. And then leave this as t. And we're gonna put this 3t squared here. So again, don't worry about this 9. We'll put that in the back. Quickly integrate that. What's that?
Plus 2t squared minus 16.
And I hope it makes sense. If this is t, it happened here, it will happen over there too, no? plug in that t is t and then 0, but it doesn't always happen. You'll see it in like in a couple problems that you just gotta be careful. But with quadratics or whatever, it'll just be that and put the plus 9 here. Is it plus 9? Yeah. And then that's it. But sometimes it's not always true that we can just go ahead and do that like that. All right. Oh, for exponentials, it wouldn't work just like this. Whatever. Okay. 3. Let's go to problem 3. Einstein's very impressed by your work here. His eyes are popping out. He's just really impressed. A particle moves in a straight line so that t greater than or equal to 0. The acceleration is given by this. At time t equal to 0, the velocity of the particle is that, and the position is that. Find the position function s of t. Same kind of thing, no? Just a little. So we're gonna have to go to V of t. What do we do? So how do we do this? V of t. Time equal to 0 plus 2 t. Okay, 12t. So, what is it? Integral is what? What's the integral of this? Really? Plus, and you see this thing again, t over z is plus 2. Because if you plug it in, then no. Yeah, it's good. So that should be v of t. For this. And then we do this s of t. And then what? S of t is what? 0 what? Is it like that? Is it this easy? And t? This is the same? Same procedure? And so it's what? 0 to t? What is it? T to the third? What is it? 3? No, 2? 2? And then what? Plus 2? T? Because 0 to t, this 0 to t thing is going to be the... The book does it a different way. It does its own way, but this is pretty, this is the same, just too much work. You don't have to be doing all this. Just like that. If you understand what happens with the 0 to t. Alright, let's go to 4. I don't have it. What did I do with that one problem I said? I took it out? It's not always true. I don't know. Maybe I do have it coming up where it's not always true that it will happen like that. Yeah, the same thing without words, without saying it's a particle moving, this and that. This is the velocity. The velocity function is 3x squared plus 2x, and they're giving you that at time equal to 2 is at position, it's a 3, and then f of 1 would equal to what? So what? You could just say that this is A and this is B, no? Yeah. So it'll be what? F of B, which is f of B is what are we trying to get? F of what? F of 1 will equal 2. Is equal to what? What do we put down? The lower limit is what? Well, lower limit is what? 2. And then this is 3. Plus, this is what? 1. What the heck? And then we're gonna do this 3x squared plus 2x dx. What? It's backwards. Could we just do it? Okay. F of 1 is okay. Let's integrate this. Yeah, let's just do it like this. We could like switch the value and put a negative in front of it, but let's just do it like this. See what it does. So the integral is what? X cubed plus what? X squared. Let's just do it like this and put the plus 3 here. So yeah, let's work it out. I mean, this thing minus, just be careful. I'll put brackets around this other one here. It's mostly not messing up. And then this plus 3 is here by itself. And so this is 2 and this is 8. Did I do something? What is this? What did I do? This is squared, no? Don't make mistakes. What is this? Plus 4, 12? -7? Yeah. There's the one. That's the one I was talking about. That is not always the for exponential ones. For doing them this way, you have to just be more careful with it. So it's another one like the other ones we did for time t greater than 0. There's the acceleration, time equals 0, velocity is 2, position of particle is 4. What is the position of particle at t equal to 2? You want to do it? So we're going to do what? V of what? What are we trying to, what is the position of particle at t equal to 2? V of t? Because we only have, so what's this? 0 plus what? This one 2 here, and this is t, and this is so we integrate. So how do we integrate? So how do we integrate this? Interesting. Very interesting. So when you integrate, it's going to be e to the negative 2t. But when we take the derivative, what was it when we took the derivative? Say when we took the derivative was y e to the negative 2t. What's the derivative of this? What's the derivative of this? Negative 2t e to the negative 2t. So if when we take the derivative, we put it right in the front, we times it, what do you think maybe we should do? Product divide? The derivative?
Wait, do you multiply?
Oh, no, it's negative 2. Yes, negative 2. The derivative of negative 2t is negative 2. Put it in the front. If we put it in the front for derivative, what do you think we're going to do for integral? If we multiply for derivative, what are we going to do for the integral? Divide it by negative 2. So we're, instead of putting it in the front, we're going to divide by negative 2. So So make sure we divide by negative 2. That makes it what? Negative 6? Yeah? I hope I'm right. Plus, then what? What? 90 squared. And now, here's what I'm going to tell you guys. That it is not going to be just that when we do evaluate. See, when we do evaluate here, from 0 to t, it's not going to fall out plus 2. This is going to be t, plug in t, it's the same. It's going to be negative 6 e to the negative 2t plus 9t squared. And then we're going to subtract and plug in 0 here. T 0. This one's going to go away. See, this one's going to go away. And put the plus 2 here. All right. So this is going to go away. But then this is going to be 0. This is 0. E to the 0 is what? 1 times negative 6 is negative 6. So you would have messed up if you just got forgot about it. So this is going to be negative 6. So then this is going to be what? Negative 6 plus 2 is what? Hold on here, hold on here, hold on here. This is what? Minus what? Which is plus 6 plus 8. So you got to be really careful with exponential ones when we're doing this. So then this would be v of t equals negative 6 e to the negative 2t plus 9t squared plus 8. So now let's do it again. What is the position of particle at S of 2? What do we do? 0 here? Plus what? 0 plus what? What goes in here? 4? 2? Negative 6 e to the negative 2t plus 9t squared plus 8 dt. Integrate that. Three e to the negative 2t three t cubed plus 8t from 0 to 2 plus the 4 yeah, you just gotta be careful with that one part. So plug it in. this whole thing is gonna go be 0, 0 plus 0 plus 4. 3 minus 3 plus 4. Is that plus 1? Is it? What? 3e to the negative 4 plus 24 plus 16. Plus 1. 24, 16, or 41. 41? 3e to the negative 4 plus 41? I don't know. Is it? Let's see, what is it? What is it? All right. So that is